So today we are going to start with our topic 4.2, that is acid-base titration. Now basically, acid and base, we all know that acid are those which have H positive ions or which give H positive ion, and bases are those which give OH negative ion. But what we mean by titration? What is this titration? If you simply look at this definition, a titration is a technique to accurately measure the volume of one solution that reacts exactly with the other solution. Okay, so this is a definition of titration, but for the layman language or for the easy definition, you can say that titration is nothing but it is a technique which is used to measure the quantity or which is used to find out the quantity. Fine. So titration is basically a technique. Now, if you remember in our previous lectures, we have already done the salt analysis. Now, suppose you have water, and in water we have suppose ammonium chloride is there. So in order to find out what amount of ammonium, what is present in water, whether ammonia is present or not, so we do an analysis that is known as a salt analysis or a quality analysis. Now, if we need to find out what amount of ammonium chloride is present in a particular amount of any solution, or if you want to find out whether that what is the quantity of a particular substance is present in a solution, then we do titration. So basically, titration is a technique in order to find out the amount of a substance or in order to find out the quantity of a substance. Clear? It can also be used for the finding of concentration of solution, to identify the unknown chemicals, and to finding the purity of a substance. So with the help of titration, you can find out three things. The first thing, finding the concentration of the substance. Concentration, what amount of substance is available in per liter, per gram, per ml, whatever we have. Then purity, is it pure or not? What amount of purity is it there in that particular substance? And you can also identify the unknown chemicals. Clear? Now, basically, in titration technique, we measure the volume of one solution that reacts exactly with the another solution. Now, suppose I have 2 ml of HCl and 2 ml of NaOH. Now 2 ml of HCl and 2 ml of NaOH is going to react with each other and give you some sort of salt. So they will react fully. Okay. But if I have 2 ml of H2SO4 and again 2 ml of H2SO4, sorry, 2 ml of H2SO4 and 2 ml of NaOH, then the reaction will be a little bit different as per the stoichiometry. Okay, because 2 ml of H2SO4 will completely, you can say, react with 4 ml of NaOH, not with the 2 ml of H2S, 2 ml of NaOH, because they require 4 ml. Because H2SO4 is going to produce 2 H positive ion. Clear? Okay. Now, if we start with the titration part. Now, titration, what definition we have understood? So it can be asked in a 1-mark question that what is titration and what are the uses of titration. So you can write titration is a technique used to accurately measure the volume of one solution that reacts exactly with another solution. And titration can be used for finding the concentration of a solution, identification of a unknown salt, and finding the purity of a substance. Clear? Any doubt up to this point?
No, that's fine.
Okay, finally. Okay, then checking the purity is an important aspect of quality control, especially for the compound manufactured for human use, such as medicine, food, and cosmetics. Now, the third is finding the purity. Now, it is not like that we have some substance, we need to find out purity of that, whether it is pure or not. This type of things are used whenever some, you can say, medicines is produced or not. Now, suppose if you see paracetamol, I hope you know this paracetamol medicine. Yes or no?
Yeah, I do.
Okay, now, so suppose any medicine if you are eating, so whether it contains the exact amount of dose that is required for patient or not. So for this, we need to check the purity. Clear? So
yeah,
for this thing, we need to do titration. We dissolve this particular tablet in water and then do some titration part of calculations are there. Then this thing is done in the, mostly it is done in the case of food industry, medicines, and cosmetics. So checking of impurity is an important aspect of quality control in order to maintain the controlled quality. It means that the quality will not change every time that the exact amount of particular salt is there or the particular compound should be there in this medicine. So in that case, we need to find out the purity of substance. We need to check the purity of substance regularly. It is essential that pharmaceuticals have a high level of purity. Just a tiny amount of any impurity in a drug would cause a great deal to harm to a patient. Now, suppose if I say this paracetamol or any other medicine, they should be pure. If there is any other impurity in it, so it will not a good sign. If suppose medicines are having some impurity, then it will create a new problem. Or if medicine is not that pure, it means what will happen? That it will not cure you that properly. So in both the cases, if it is having it is not pure, if some impurity is there, so it means it can create a difference in the treatment of patient. Clear?
Yeah.
Okay. Now for this titration part, we used to prepare a standard solution. So a standard solution is a solution of known concentration. Now, suppose you have something unknown, fine. To titrate this unknown thing, we should titrate, or we are going to, you can say, compare it with the known concentration. And the known concentration solution is known as a standard solution. Now, suppose I have a beaker of unknown salt. Okay, beaker full of unknown solution. So I'm not aware of it, what is there inside of it. So what I will do, I will prepare a known salt concentration solution. For example, I will prepare 100 centimeters or 100 ml of, you can say, a NaOH solution of molarity 1/20, 1/40, something like that. Clear? So that solution with having a known concentration term is known as a standard solution. Now, a volumetric flask is used to make up the standard solution. I think volumetric flask यहाँ पे दिया होना चाहिए. They have not given volumetric flask. Volumetric flask क्या होता है? It is like a flask. एक सेकंड में दिखाया था इसको कैसा होता है volumetric flask.
Is that
I hope you know volumetric flask.
It's on the textbook.
एक सेकंड. कहाँ पे?
It's on the textbook.
This one?
Yeah.
This is the volumetric
Under
flask,
it.
but this.
Under that's the volumetric.
No, this is not the volumetric flask. This is a flat bottom flask, or you can say that volumetric flask is also, because it has some sort of, you can say, marking over it. Okay. Now basically, what is volumetric flask? It can be a 100 ml, it can be 200 ml, it can be 250 ml, 150 ml, 200 ml, 180, 1 liter all. Okay. Basically, how this marking is there, I will tell. It has something like this. Okay, and it is flat at bottom, and here you have a marking. It means up to this thing it is 1 liter. It may be a 500 ml, a smaller one can be a 500 ml, 200 ml, and you have given with the stopper. This is volumetric flask. Fine, and then we have a beaker, something like this. On this beaker we have a marking. This is known as a measuring beaker. Okay, so if there is only a one marking in a particular flask or in anything, so it means we call them as a volumetric. But if there are number of markings, then we call it as a measuring beaker. Clear? Then we call this a measuring flask or measuring. You can say that any item which is used for measuring things. Got it? Clear?
Yeah.
Okay. Okay. Now see, a volumetric flask is used to make up a standard solution very accurately. Now, what we are going to do in this, volumetric flasks are manufactured in various sizes and can measure the volume very precisely. Volumetric flasks that you will use are manufactured to a typical tolerance. Tolerances below 100 cc centimeter cube, that is 100 ml, 250 ml, or there can be a plus minus of 0.2, 0.3 centimeter cube. So this volumetric flask can be of 100 ml, 250 ml. It also there in case of 500 ml, 1 liter, 2 liter, 3 liter. depending upon your requirement. There are so many volumetric flasks. Okay, clear?
Yeah.
Okay, ji. Now if you remember, okay, if you see this, I told you there is some marking on that neck. There is a marking on that neck. Okay, neck. Now this marking is little bit is something like this. If you see this line, this is the marking on the neck of a volumetric flask. Now, whenever you are filling any solution into it, that this solution always any solution has something like that of meniscus. This top layer is known as a meniscus, and the lower this meniscus is a little bit arc. So this lower portion should touch the marking, not the upper portion. It should not be like this. It should not be like this. It should be like this. If you see this, this is the meniscus part. Here,
Yeah.
okay. So the volumetric flask is filled so that the bottom of the meniscus just touches the graduation line. Graduation line is this marking. Clear? Okay. Now we will see how we are going to prepare a solution. Now, first of all, a solid is weighed accurately. Now, it means solution means some solute and solvent. So what we are going to do, first of all, we take any solid of which we are making solution. So we need to weigh the particular solid very precisely or very accurately. Now, solid is dissolved in beaker using less diluted water, less distilled water, and then we will need to fill the volumetric flask to the mark. Now, what we are going to do, so, okay, suppose this is your volumetric flask. So we took small amount of water in it, okay, and add that salt and try to dissolve in it, okay. So it will dissolve in it. We used to stir it, we use all these things and then dissolve in it. Now, once all this dissolution takes place and all, if you see it, that everything is transparent, nothing more than is there, then we add more amount of water up to this marking. We add more amount of water up to that particular marking. Clear? That is already written there. A solid is dissolved in a beaker using a less distilled water, then will be needed to fill the volumetric flask to the mark. Clear? Third point is this solution is transferred to a volumetric flask. Now this solution is transferred to a volumetric flask. The last traces of the solution are rinsed into the flask with distilled water. Now that you are doing it, suppose in some separate beaker. Now you need to put all the things into that particular volumetric flask, and whatever the last amount of things are there in that particular beaker. So okay, wait, I will show you. Suppose you are making this in this beaker. You are making a salt solution in this beaker. Okay, so you're making a salt solution in this beaker, salt solution in this beaker. This is your water, and we are adding some salt into it. Now, if you dissolve it after some time, maybe there are some particles that is there. So how we are going to take each and every particle? So you pour it into this volumetric flask. After pouring, you put a little bit amount of distilled water in this, and then again you can say stir it, and then again pour it into the measuring flask up to this 1 liter. Clear? Any doubt up to this point? Now the flask is carefully filled with the graduation line up by adding the distilled water. Now add up the distilled water into the flask. Water, a drop at a time. Now see, the flask is carefully filled to the graduation line by adding distilled water, a drop at a time until the bottom meniscus lies up exactly with the mark. Now you need to fill this up to this mark. It's not like that you fill first there and then you take out from this one and then you can say drop it down. No. Up to this point, fill it and then add drop by drop, so that the upper meniscus will be, suppose this is a marking, the upper meniscus will be something like this. Clear?
Yeah.
Got it? Okay. Now the flask is carefully filled with the graduation line by adding the distilled water a drop at a time until the bottom of the meniscus line exactly with the mark that is given in the figure 1. Care at this stage is essential. If too much water is added, the solution will be too diluted. Why? More amount of water in less amount of solute, so it will become a dilute and must be prepared again. So we need to prepare that particular solution again because it will not be that of the known concentration. You should view the graduation mark and meniscus at eye level for the accuracy. Now, whenever you are measuring this graduation mark, so it should be in the eye level. It's not like that you are standing below it, it is up, and you are looking at this one like this. No, or it is below, or you are looking like this. No, this is wrong. It should be in the range, or it should be in the straight line. So your eye and the upper meniscus should be in the straight line whenever you are watching this particular marking. Clear? Any doubt in this?
No.
Okay. You should view the graduation mark and meniscus at the eye level accurately. Now the final point is that finally the volumetric flask is slowly inverted several times to mix the solution thoroughly. Now like this, you need to just mix them by putting the stopper. You need to just shake it a little bit so that it can be mixed several. It can be mixed several times to mix. You can invert it or shake it several times so that the whole salt into it will be mixed thoroughly. If the stage is omitted, if you omit this stage, maybe titration results are unlikely to be inconsistent, and you will see a solution mixing when you invert the flask as more dense original solution moves through the solution. So you can clearly see that solution is mixing or not. Fine? Clear? So this is also necessary. Okay. Now this is the way to prepare the standard solution. Now there are two questions. Explain the effect of the titrate of the following errors. Explain the effect of on the titrate. The first one is the flask is filled with water above the gradation line. If you filled more amount of water, the solution will become diluted. Then it will be again. You need to prepare it again. The point is, so if the flask is not inverted, if you do not invert the flask, then the solution will not be thoroughly mixed, and you are unlikely to get the consistent results. You will get a range of results. Clear?
Yeah.
These two questions are clear. So for this question, we have point number. Okay, so these two questions are there in this only. Okay, fine. Now we have an apparatus. If you see this apparatus, this is a knob. This blue portion is a knob. You can open or close it. And if you can see this white portion, if you open it, this white portion will move out. If you close it, this will move inside it. Yes, and this is known as a burette. And there's one more term known as a pipette. Now, pipette and burette. I will show what is burette and pipette. Now, suppose this. This is known as burette. This is burette. It has a marking 0. Something like that, that's marking. Fine. Like it is 0, 1, 2, 0, 1, 2, 3, 4, 5, or maybe 10, 20, 30, 40, 50, something like that marking are there. This is stopper. This is stopper. Or you can open it or close for opening and closing of burette. This is burette. For this is used to open and close the. This is used to open and close. Open and close the what we call open and close the burette flow of liquid from open and close the flow of liquid from burette. Here, this is burette. Now in this burette, we fill the solution. Now again we have one more thing known as a pipette. Pipette is also drawing अच्छी नहीं बनाएंगे. Pipette is also something, a straw sort of thing is there, but little bit you can say less diameter. Okay, and it is having a marking there. This is available as a 20 ml, 25 ml. Okay, this can be equal to of this is 60 ml or 40 ml something, 60 ml, 50 ml, 100 ml. It is available something like this. Fine. Now this pipette can be used. It can have this sniffer there, or it can be you need to suck liquid in this, and so that it will rise up to that point. Sometimes we need to suck it also. Liquid. Okay. So in acid-base titration, a solution of acid is titrated against a solution of a base using a pipette and a burette. So whenever you have an acid-base titration, so we need to titrate an acid as well as a base, and this can be done with the help of a pipette and a burette, which are typically manufactured with a tolerance below a 10 centimeter cube, 10 cc pipette. Pipette can be of 10 centimeters, 25 centimeters, 50 centimeters. Mostly in our schools and in India, mostly we are not having this 25 or a thing. We have 20 ml, 20 ml or 20 centimeter cube. We can say that, but in maybe in this UK market, you have 10 centimeter, 25 centimeter. Okay, so mostly we use the smaller one. This 50 centimeter wala thing is not used that much. Now, a burette reading is recorded to measure the nearest half division with the bottom of the meniscus mark on the between the two marks. Now, a burette reading is recorded to the nearest half division. So whatever the nearest half division is there in the burette, so we need to make it, measure it. What the nearest half division means? If suppose marking is coming like this. Manya, am I audible? Now we need to measure this. So it is coming as a 10.3. So we need to measure it up to a decimal point. 10.3, 10.2, 10.2 is there. So we need to measure the exact marking in the case of burette. Here. So the burette reading is recorded to the nearest half divisions with the bottom of the meniscus on the mark between the two, with bottom of the meniscus, the bottom of this meniscus. This is touching the mark. Okay, so bottom of the meniscus on the mark of the between the two marks. If there are two marks are there, so the bottom of the meniscus is there. Whatever the bottom of the meniscus is showing, so it is going to be the reading. So each burette reading is measured the nearest 0.05 centimeter cube. So the reading always has 2 decimal places. So always take the reading up to 2 decimal places. So the last place being is either 0 or 5. So you can take it as a 22.4 or 22.5 or 22.0. It can't be like that 22.43. Okay, wait. It can be up to decimal point. So 25.40 is good. 25.30 is good. 25.35 is good. But 26 or 26.25 is also a good thing. But 25.43, 25.42, these values things are not there. You should avoid them. Clear? Any doubt in this? Acid-base titration apparatus part clear?
Yeah, that's fine.
Okay. Now we have acid-base titration procedure. Now listen carefully, this procedure part. Now you can clearly see this. This is a burette one. So it is 25, 25, 25.1, 2, 3, 4, and it is in between it 4 and 5. So it will become 22.4 comma 5. Clear? This reading will become 22.45. Is that point clear? Yes or no?
Yeah, it's clear.
So reading is done from the upside. Up is here, something is here, in this case 0 is there. So you are using the solution titrating against, and then you are taking a reading in this time. So this is done from the upside. Upside is 0. You can't write like this at 26.12345. No, it is not like that. Clear? Got it? Is that clear? Any doubt?
Yeah.
You can clearly see this also. This is the reading is 22.55. This is 1, 2, 3, 4, and 5.
Yeah.
2, 3, 4, 5. ठीक है, clear है? चलो जी, आगे देखते हैं. Let's see now. Now, the acid-base titration procedure. The first is add a measured volume of the one solution to a conical flask using a pipette. Now, अब ये conical flask क्या चीज होती है? What is this conical flask? This is conical flask. It is conical in shape. This is another conical flask. Now, with the help of this pipette, you need to measure the solution and put it in the conical flask. Here,
Yeah.
to measure a volume of one solution, you can take any other one solution to a conical flask using a pipette. Now, the another solution you need to add it in this burette. One more thing, whenever you are doing this experiment, before adding the solution into the burette, you need to remove this gap. If there is any gap is there, so you need to remove this gap. How you are going to remove this gap? Just open it slightly. This gap will move out, and then again stop it, and whatever the remaining portion which is out, so then again fill it. So please check whether these gaps are there. Gaps should not be there. These are the air gaps which should not be there in the burette. Okay. So add a few drops of indicator to the solution of the conical flask. Now, in this solution, now if you see in this conical flask, you add solution with pipette. Clear है वाली बात? Is that point clear?
Yeah,
And
that's
then
clear.
add some amount of H2SO4 or acid. What was written there? Add a few drop of indicator. Sorry, indicator, not acid. You need to add few drops of indicator. Okay. Now indicators are those compounds which indicate whether reaction is finished or not. Okay, it or indicates the this reaction is going to give a chemical change. Clear? Or you can take it as like that also. So in this case, we add an indicator. Now indicator can be KMNO4, it can be phenolphthalein, it can be dimethyl ether. So the different indicators are available depending upon what we are going to do in this thing. Okay. So a few drops of indicator to the solution in the conical flask. Now run the solution of the burette into the solution of the conical flask. Okay, now I will show you what this indicator does. So basically, indicator is of some specific color. Now this acid, if it is putting there, if you are putting this acid into this solution, it will show some color and it will vanish out. Now after some time, this whole solution will be little bit some other color. A very minute little color is observed in the particular solution. Now if you add one drop of H positive ion into this, it will again come back to KMNO4. Or you can say that it will again come back to indicator. Is that point clear?
So it would come back to,
It will come back to the original, you can say. As you add any point, as you add any indicator into it, indicator again, it will again, you can say, okay, no, I will tell. You have a solution into it, okay? Now add indicator.
yeah,
Add indicator, okay, fine. Then you need to add solution from the pipette. Reaction is taking place. There is a point on at which this indicator changes color. So this point means that the titration is finished now. Clear? Okay. If
yeah,
you
I
add,
get that.
okay. Now how you can confirm
Yeah.
that this change is the perfect one or not? Now, if you again add a drop of indicator into it, this color will vanish out. Clear?
Oh, okay, yeah.
Got it? So this is the indicator. KMNO4 act as a self-indicator. KMNO4 act as a self-indicator because it is of pink color. We do not require, if we are using KMNO4 in burette, so we do not require any special indicator because of this. Because KMNO4 is itself a indicator. Is that point clear? Any doubt in this case?
No, I get that.
Now, whenever we are doing this experiment, now this particular color changes. Now we need to note down that reading. That reading is known as the endpoint. So this color change means the endpoint, and the reading is need to note down the reading also. Okay, now run the solution of a burette into the solution of the conical flask. Now run the solution in the burette into the solution of conical flask, swirling the conical flask throughout the mix of two solution. Now you need to swirl it continuously so that it will mix together. Eventually, the indicator changes the color at the end point of the titration. Now, as the color changes, at that point is known as the end point. The end point is used to indicate the volume of the solution that exactly reacts with the volume of the second solution. Now, in our burette, there is one solution, and in our in our burette, there is one solution, and in conical flask, there is also one solution. Now, as soon as this color changes, we need to take note of the burette reading. We need to take the note of the burette reading. If this burette reading, okay, we need to note it down. Burette reading, suppose it is coming 20 mm. It doesn't matter, it may come more or it may come less. Suppose it is coming 20 mm. So we need to note down this particular reading. The end point is used to indicate the volume of the one solution that exactly reacts with the volume of the other solution. Now at that point, there should be you can say some amount of, I will say at that end point, some amount of any one solution which is present in this burette is used. Yes or no? Some amount will be used. Now it means we are now having a known one. Clear? My voice is clear? Okay.
Yeah.
So run the solution in the burette into the solution in a conical flask, swirl the conical flask throughout the mixture of the two solutions. Eventually, the indicator shows the endpoint of the titration. You need to swirl it, and you can see it to swirl it at the fixed rate. You need to move it, shake it. Not shaking means little bit of shaking, swirling, what we call it. Eventually, the indicator changes the color at the end point of the titration. Now, as there is an end point, you can say that end point means that change in the color. So, indicator changes the end point of the titration. This point is clear, yes or no? Anji, Manya, this point is clear? I'm again repeating.
It is. It is.
Run the
I get
solution
that.
in the burette into the solution in the conical flask, swirling the conical flask throughout the mix and the two solution. Eventually, indicator changes the color at the end point of the titration. The end point is used to indicate volume of one solution that exactly reacts with the volume of the second solution. Now, as the endpoint is reached, it means that some amount of substance which is in the burette is used, and the some amount of substance which is there in the uh, conical flask is used. So you can clearly indicate the substances amount. So thus the point is used. Okay, now the end point is used to indicate the volume of the solution that exactly reacts with the volume of the second solution. Is that point clear? In this point, fourth point, any doubt?
Yeah, it's clear.
Yes. Okay.
No, it's
Fifth,
fine.
fifth point, what it is saying, record the burette reading and the volume of the solution added to the burette is called the titrate. So you need to, it's up to you guys. You can fill up to 0 again and again, or you can continue with that. So we need to record it, final thing, and which is calculated by the subtracting the initial from the final burette reading. So you can do it very simply. Now a quick trial titration is carried out first to find out the approximate titrate. Now, sometimes we do a first titration, that is a quick titration, and in this we just simply try to find out what amount of solution will be required to titrate it against that particular unknown solution. Now, the titration is then repeated accurately, adding the solution dropwise as the endpoint is approached. The titration is then to be repeated accurately, adding the solution dropwise. Now, in this case, we need to add the solution dropwise as the endpoint is approached. Now, the further investigations are carried out until accurate tires are concordant, agreeing to within 0.1 centimeter cube. Is it point clear? Seventh point is clear or not? I'm again telling
Yeah.
a sixth point. A quick trial titration can be carried out first to find out the across titrate required. So what we can do a first quickly, we will do a short type of, you can say, this titration part, and this short thing can be used to, you can say, just to extrapolate if we have that much amount of substances or that much amount of, you can say, things we need to titrate it, then at what we have to do. So it gives that particular idea. So record the final burette. The volume of the solution added to the burette is called as titrate, which is calculated by subtracting the initial and the final amount of the burette reading. So then we need what amount of exactly this particular solution, which is in beaker, is used in all the three cases. And it should be same. We can take 3 or 4 reading, and mostly there's a little bit amount of differences there in between these. Got it clear?
Yeah. That's
okay.
fine.
Okay, fine. The further titration carried out until the 2 accurate. Okay, fine. Leave it. Now, question is, explain the effect of titrate on the following purpose. The pipette has an air bubble inside it. Air bubble inside it means space inside it. It will be it will not. It is simply air. It is not any acid or anything. Clear? So that's why it is of no use. Now, these two questions you will do as a homework. And previously also there are 2 questions. These are also homework. Clear? Any doubt in this? Okay. Now, what do you mean by titrate? So when working out the mean titrate is important to use only your closest accurate titrate. Now, by repeating the titrate until to agree within 0.1 centimeter cube, you can reject the accurate titrate. So these are nothing but the initially whatever we are doing, the first thing, the second, this is known as the titer. Clear? Any doubt in this?
No, that's fine.
Okay, if you were to include the titrate in the mean, you have lost the accuracy of titration technique. If you were to include all the titrates in the mean. Okay, now Now, sometimes suppose you are, whenever you're doing calculation, you got answer as a 8, and then you are getting answer as a 12, and you are getting answer as a, you can say 8, sorry, not 8, 12, it will not come. It is something like that 8, and it is coming as a 10.2, and it's coming as a 10.5. Here 10.2 and 10.5, and the size is around 10 only. So that requires, so if you were to include the titrate into the mean, if you need to include them into the mean, then you have lost the accuracy in titration technique. So this titration technique cannot be used. What are the readings are there? It is not like that we can take a this average of these. Clear? Is that one
Yeah.
clear? Any doubt?
Yes, clear. No.
Okay. Now we left with the titration calculation. So there is one simple calculation is there now. We need to understand this calculation. And okay, then that is all for today. So as a homework part, you can do these 44-page and previous questions. So in our next class, we are going to discuss about this whole titration calculation. Okay then, bye-bye, take care.